Hello, everybody. I'm Everton de Oliveira from the Groundwater Project, and today we're going to interview two very nice professors, great authors of the book about urban hydrogeology and talking about quality in urban hydrogeology. We're great to introduce you to Robert Pitt and Shirley Elizabeth Clark. Pitt is an emeritus Scudworth Professor of urban water systems at the University of Alabama. And Shirley Clark is a professor at Penn State Harrisburg University. Thank you very much, both of you, for coming here today. And we're everyone at home having fun talking to the Zoom all the time as you're getting used to it, right? Please tell us a little bit about your career, how you focused hydrogeology first and how urban hydro next. Both of you, who's first?
At the same time, right? I've been involved in urban stormwater issues for a number of years, and starting probably in the 90s or so, in the late 80s, we started looking more and more into groundwater interactions with stormwater. I was involved in a National Academy, report on recharge of groundwaters with waters of impaired quality, including stormwater and ag water and other things. And I was working with the stormwater aspect of that and learned quite a bit. And that pretty much got us going. Shirley worked with me at that point to put together a separate book addressing those issues based upon the literature. And then in the 90s, I started dealing more with field investigations and looking at disturbed soils and how that influenced the interaction and interface between surface and stormwater and groundwaters, and then developing methods to restore soils, to methods to treat stormwater before infiltration and issues like that. So it's kind of drug along with my interest in stormwater, and certainly becoming a parallel interest.
Yes, I was going to say, obviously, as Bob said, I started working with him as part of my graduate degree and working on the first report that we did on that. But from a research standpoint, working with him also, I started looking at the treatment of urban stormwater runoff and using natural media filters. And when you start talking about things like that, we are talking about treating urban stormwater for eventual groundwater recharge. And so a lot of my look at the literature actually dug into the water quality issues associated with groundwater transport and understanding the reactivity of soils as part of that. My undergraduate degree is chemical engineering, so this fit in very well. And so that's where I really started with it. I've continued some of the issues of disturbed urban soils and the challenges of doing infiltration and groundwater recharge and quantification, recently focusing on flooding, because we're not putting enough water back into the system to balance out the system, and also continuing a project looking at urban salt movement, road salt movement through urban soils and through stormwater treatment systems. So, and I do teach our groundwater hydrology course, and so I'm looking forward to all these publications. My students are looking forward to a free textbook. They just don't understand how many pages each of these chapters are. So groundwater hydrology in the fall.
Yeah. You did a great job for a start. That's very good. That's very good. So you guys divided your book in two. Now we'll have two books from you. One is quality, the one that we're going to focus today, and the other is quality. Why so? Are the topics totally independent?
No, actually, we prefer to integrate them together and to people study quality and quantity together. They pretty much got separated for technical reasons in our production and timing of assembling these. So I hope that the readers will, of course, consider both of these pretty much simultaneously, because as we all know in this field, we can't ignore one aspect and focus on the other. We really need to and consider both quality and quantity, surface and groundwater both. So again, there are a lot of different aspects that need to be considered together. So, it's just more from a packaging standpoint and timing standpoint of why they became separate.
Sure. And I think this has also been one of the challenges across the board, whether it's groundwater or surface water, or the interface. A lot of our modeling that we use to make decisions also is very separate. And I think we're beginning to, with the computer processing power we have, trying to incorporate everything together, but it's still a bit of a challenge. You know, in some of the surface water models I use, the groundwater component is very, very simplistic. And in the groundwater models, it's a little bit more simplistic on the surface edition. And so that's been, hopefully if people are looking at both of the books together, which is what we really hope, is that they'll see how heavily integrated these are, the subject is.
Yeah, I had the opportunity to review your books. They're very good. Congrats for a nicely done job. And I'm pretty sure that the readers will have a good opportunity to see them together. And I think I agree with you. It's easier for them to download separately and then use them together. It's much easier to work the book. I agree with the initiative. It was very good. So let's go to the book then. Cities change the original natural environment in many ways. In your view, in terms of quality, what are the main changes that affect the groundwater? Why is this important for people living in cities? And what about the future generations?
Well, certainly, as I mentioned, we've been studying surface water quality issues and stormwater for a number of years. It's not well recognized still in many places. Obviously, in many cities around the world, there are a lot of other more important issues, sanitation, fresh water supplies. You know, those really need to take probably precedent, obviously, from a public health and safety standpoint. But we do find that we really don't want to sacrifice the groundwater quality, especially in many cities where the groundwater underneath the city is the primary water supply. And so that's a great consideration, irrespective of surface water issues and the environment itself. But it basically is it's a long-term protection. As we all know, once you contaminate groundwater, it's very, very difficult and time-consuming to reverse that. So it's important that we do as little contamination as possible, but we still have to recognize the other, urban water problems and try to address those collectively, but we don't want to sacrifice groundwater for that.
And as an illustrative example, I actually live in a town that is next to a contaminated water site on our airport. Our airport was built on a military base. And so back in the 1950s, they weren't very careful with where they disposed of certain chemicals. And so it's created a concern in the area that the groundwater is contaminated, which people do not understand that it's regularly tested. So anything we can do to do that, to keep people understanding that the groundwater is safe in a lot of places. And also, again, for places where they are using groundwater straight from wells, it's critically important where they're not going through a treatment system, where you do have the poor who are getting water wherever they can to try to protect that groundwater system.
Yeah, that's true. Very good, very good. So your book focuses on the United States, right? It's clear from starting from the title of the book. How do you think your experience may be helpful for other cities and other climates, for example?
Well, I think it's highly relevant. Much of the information and research that we had available was projects that we had worked on, in the region, certainly, but there are areas elsewhere internationally. As I mentioned, an NRC report that we did many years ago had a lot of international contributions associated with that, but again, it just, people deal with urban water differently around the world, but but I think that we're offering information that is highly relevant elsewhere also. We find little difference in a lot of the basic characteristics of hydrology and quality and quantity, in other cities, the social economic conditions, but, rain runoff processes, infiltration processes are similar in basic form, but we just have to consider what the local characteristics will influence that. But I think that the information that we provide should be useful and relevant to folks elsewhere too.
And I think one of the advantages with the United States is this is a, this country does span quite a few latitude zones and quite a few climate zones. And a lot of our work has been done in different places around the country, and we've summarized that, whether it's our work or other work. And so we do have data and information in there that is relevant to a lot of different areas. And we've also, I think, in there shown some of the similarities that as Bob was saying, water quality is a challenge anywhere. And I don't think in some cases, and we start looking at migration of pollutants, that soil characteristics are that different based on just general texture classes and organic content and pH. That's universal. So I think we do have some of that information that translates very well to other places around the world.
Yeah. You're saying something? Okay. So I think it translates very well. Well, just one point. When Bob, he used this.
He used a safe term to edit it out.
Good. Okay, guys. So the major impact of groundwater from cities is the decrease in infiltration of stormwater due to surface impermeabilization, right? Nowadays, in many places, there are concerns and utilities are being created and installed to allow infiltration to compensate for the loss of the infiltration capacity. What special care should be taken when only or mainly quantity is concerned? Should we care about quality or just infiltrate? That's what I have that question because I talked to many hydrologists and most of them couldn't care less about quality. They just infiltrate whatever is in there, right?
Yeah.
Please.
Yeah, I'm afraid that is not an uncommon approach. Just like the surface water folks, water is a common enemy. It's written in Western water law. You can get rid of your water and it's not your problem anymore. It's somebody else's problem. But groundwater, as we mentioned before, stays around for a long time in most situations. And so we need to consider that. And as we mentioned about the 2 books and all the other books in the ebook series, we really need to consider quality and quantity issues together. In our writings, we talk about water that's relatively safe to infiltrate with relatively minimal type of pretreatment if we do certain things, mainly most residential areas. If we are infiltrating through surface soils, the swales and other features, or bioretention facilities, we're probably okay. But once we start going into deeper trenches or injection wells and going into more contaminated waters, such as industrial areas and even some commercial areas, it becomes obviously much more problematic. So there's a huge scale of issues there, and too many folks don't recognize that there are differences like that, and they're really not being careful enough in some situations. A lot of regulations only focus on one part and not the whole thing collectively. It's been very challenging.
Yes.
Well, I think if you go back to adding on to that, I think we can go back to some of our well-known public health issues. Certainly, John Snow and the cholera epidemic in London in the 1800s was due to contaminated groundwater from sewage. Not urban stormwater, but in that era, of course, it was kind of combined sewerage running over the land. So the mid-1800s wasn't great for sewer systems. You go back to that, you go and it's maybe more common in the United States, but there are places in the United States, in the northern United States, where departments of transportation have had to buy out land and wells because they have salted out the wells. And so there's a financial impact to that also. So like up in here where I am, we're looking at alternate de-icing materials in order to try to provide still the safety that we need to, while not contaminating the groundwater, because honestly, the taxpayers don't want to buy any more land than they have to. So there's kind of that interesting mix of we're trying to balance out the various applications or uses in urban areas for people's lives with this idea of trying to also protect the groundwater. So, and of course, one that with not as much quality as it is quantity is the issue of land subsidence. So, over pumping of groundwater and not being able to recharge. I think if I was remembering your question right, also one of the other issues, and maybe this is a different question. I'm in an area with a lot of karst. So we have a challenge. While you have this one challenge of we want to infiltrate groundwater, but if you were to take a 2 to 3 hectare site and put a big building on top of it, you don't have a lot of land left. So now you're trying to point infiltrate water, or you've got to surface run it off. And so you've got to find that balance so that you put enough water back in the ground that you don't end up with these caverns that are going to collapse. And you've also got to not put so much in that you dissolve the limestone. So we have a lot of challenges in my area. At my house, I did make sure I didn't buy a house in this, but I miss it by like a couple of miles, a couple of kilometers. To stay out of the karst area, but that's exactly, I'm sitting on shale. These are the kind of things that urbanization, that change, forces this idea. Now we want to infiltrate, but there may be places where infiltration is a challenge because of the soil conditions themselves.
Yeah, well, basically, we do have the science for it, don't we? We just have to educate more people about it. Isn't it the case?
We have a lot of the science. So, I mean, we've been looking at that issue, and several others who are better at that than I am, who are really soil scientists, have been looking at trying to develop our guidance for karst, both to educate our engineering and design profession, as well as our regulators, because initially everybody's like, do not infiltrate in karst, period. Just don't. And then we realized that with the groundwater subsidence, the groundwater levels dropping due to pumping in urban areas, then you're creating another subsurface problem by not having water fill the cavities. So we have these interesting challenges, and so that's it. It keeps teaching fun. My students are always very interested in the karst module.
Yeah, that's the right. You're always learning.
Yes.
Good to have challenges, right? That's the idea. So you guys touched 2 points that are important that we're going to talk now. It's in many places in the world, sewage collection is poor. It's poor or lacking altogether. Have many places like in Brazil, for example, we have only 53% of the sewage is collected, and a fraction of that is treated. So most is not treated. Could you comment on the potential problem coming from this source on a city?
One of the research projects that I was involved with for a number of years was looking at what we call inappropriate discharges, to our drainage systems. And basically most folks and currently are the main addresses on dealing with sanitary sewage issues and bacteria and pathogens, getting into the surface waters and more into the groundwaters. And so we spent probably 20 years investigating a lot of those issues also, which are pretty important. Certainly, it varies quite a bit. Bacteria don't migrate much, but viruses certainly do, and let alone the other interesting micropollutants that we're identifying more and more in with sanitary sewage that can migrate quite well into the groundwater issues. A couple of my current projects we're looking at some of those issues, mainly just in the surface water, but we can't ignore the groundwater also. So again, poor sanitation conditions certainly will lead to problems, public health, number one, but also, of course, surface receiving waters and subsurface receiving waters are all of concern.
Yeah, one of the things that we're doing right now, I'm actually on one of our COVID research teams, and while we're looking at the delivery of viral particles to the wastewater treatment plant, we are also looking at the literature to try to understand how these things could migrate outside of this, because our sewage, even in an area where we do collect the sewage, we do treat it. Many of our piping systems are very old and very, very leaky, both with water coming in due to inflow and infiltration and also due to exports. And so, looking at several studies where we have seen both either phages that are being used as test tracers or others, or the viral particles for various diseases showing up, for example, in coastal areas where you're seeing it then end up in the shellfish. So it's a public health issue. And certainly, like I said, we can go back to, documented cases of cholera and other disease outbreaks over the centuries that were due to lack of sanitation. Just simply that outdoor disposal of this. One of my interesting areas that I do as a kind of a side topic is trying to understand how our indigenous villages were set up in relation to water, and wondering, nobody seems to want to address where did the sanitation part of this go. Because they would not have wanted to contaminate their fishing area, but they also may not have known, and many of these were along coastal areas with sandier soil, so you would get that migration. And where I live, the Susquehanna River is our recharge for our groundwater that my town pumps out of. I live right at the confluence of the Susquehanna River and the Swatara Creek. And so the U.S. Geological Survey has noticed that the Susquehanna, and has documented the Susquehanna as our recharge. Contaminated Susquehanna, we've got that too. So these are some of these big concerns from a public health standpoint.
For sure. Well, the other point that you mentioned was that in colder climate, I'm going to stress that for something that is very used for you guys, but not for me. Now it is, because I lived in Canada for quite a while, but I'm originally from Brazil. I live in Brazil, and I saw a stove when I was about 30 years old or something for the first time. And so you use salt to de-ice streets and roads. People in Africa don't know what that is, and in Brazil, most people don't know what that is. And it is a big problem. I lived in Ontario, and I know how big that is, right? So what is the behavior of salt in groundwater? How big is this problem? And is there a solution? And before the problem increases even further, because it's already bad in some places, like in, near Waterloo area there, where I studied, it is a problem already in Guelph. It's very bad. It's close to Waterloo, where the groundwater project is in Guelph, the NGO. So we have a problem with ice. Could you tell us, could it be prevented? Shirley mentioned something about, maybe not using salt. What's the way out of that?
Well, again, as you pointed out, we have long documented case problems associated with increasing salt under northern cities in the US and Canada and Europe also. It's not as common in Brazil or in Alabama.
No. I saw snow in Alabama when I lived down there.
Yeah, we do have a bit. So when we first moved down here, we had a couple of heavy storms one year, the next, and they bought a bunch of salt spreaders the next year. Said, "Oh no, don't do that." But whatever. Again, it's public safety and public health. That are the main issues that have public works folks have to address. The EPA has been working on investigating alternatives for salts since the 1970s. And some cities have done certain things, but as Shirley would point out, it's an economic question more than anything else.
Yeah, my local town that we're working with, their comment is that they'll buy the cheapest salt they can get, because it's just they have a small tax base of people, 60,000 people, and a good many of those are economically distressed, and so you don't have a huge tax base. And the comment that somebody used down there, and if anybody has ever had them, and this may be only an American thing of going to the theater and buying a pretzel, but said it tastes worse than pretzel salt. I wanted to know who ate that. But it's
I love it.
It's as cheap as they can get. It's still sodium chloride, and its various versions is still the cheapest salt that's out there. And so there are alternatives. Some people are switching over to calcium chloride. That does have the advantage of potentially not being as reactive with the soil as sodium is, and not causing the soil sealing. So we can do that. Others are looking at things like denatured beet juice and other organic material. And that also will do this exact same thing, which is to help prevent some of the binding of the salt of the ice to the pavement. And it also will try to depress the freezing point of water. And so what you're really trying to do is depress that freezing point of water. And if they can do that, then you can do something with that. One of the challenges, we just recently did a project that tried to use an organic, an acetate, just to kind of simulate that. And the concern we had was the development of biofilm in the soils. And so if you're giving soils an organic, if you're giving soils an organic food source, effectively you're going to encourage the bacteria, which could also change your infiltration rates. And depending on what the bacteria is, we did not culture anything out specifically other than just knowing they were heterotrophs. You could, if something were in there that was problematic, you could potentially encourage with sloughing off of a biofilm, encouraging downward movement of certain bacteria in soils. I don't know if that's a huge issue because a lot of the soil, as Bob said earlier, is good at capturing bacteria, but it has to be an issue. So other places, example that we use up here is they mix cinders in with ours. These like black crystals that I'm not sure where they get them. You used to think about cinders coming from fireplaces, that kind of part of that fireplace ash and residue. But somewhere in here, we're actually cutting down on our salt by using cinders, which will not get into the soil. They would get into a stormwater system, and it would require maintenance there to scrape those things out because they'll clog them. So that would be from my perspective. I think, I don't know what else Bob would like to add to that.
Yeah, a lot of places will add sand also to it to decrease the salt use. But I think our biggest problem is like in the 70s when I was in Wisconsin in the 80s, cars would rust out within just 2 or 3 years. Mm-hmm. The car manufacturers have gotten really good now at corrosion. And so I think that people don't have are not complaining so much about the salts from rusting their cars, but now they're concerned about road safety, which we all should be concerned about. But again, I think that there's not that pushback about lack of salt use because of car corrosion as much as there used to be. So I think it's easier now to use more and more salt basically without that consideration and concern. And again, it's trying to come up with use of a waste product locally available, that could reduce the salt use, which would be fine. That has created some other problems, but again, it just comes down to economics. Again, people expect ice-free roads. They're not willing to accept, that they have to be more careful driving under those conditions. But again, those are all social economic considerations, and salts are a serious problem.
Yeah, it's going to be
we're going to be very curious coming out of the pandemic what's going to happen, as some people are still, I've been following the news looking at work from home. If people are more willing to, and companies are more willing to let work go from home, it may be that some of the side streets, like the one I live on, don't get plowed as often and don't get salted as often. It depends on, again, you're never going to get rid of all the employees staying home because police and fire and medical staff have to go to work. And then there's still some parents who need childcare, so they will insist on kids going to school.
That's for sure.
Exactly, that's a tough call.
But in the university, my boss has figured out we can teach in the snow from our houses.
Well, but I know it depends on the amount of snow we're talking about, because if it's a lot of snow, you have to plow it anyways, right?
Well, and we just going back to that, we started late this year because of COVID. We went back to campus late. We didn't bring students back on campus until mid-February, while classes started in January remotely. And we had several large snowstorms, and I've been tracking the salt coming off our parking lots into our stormwater pond. And you can see a definite increase in the conductivity of the water coming into the pond from our parking lot as soon as the students come back. Because you can just see that when we didn't have students, that they were doing minimal maintenance. And so that's going to be that documentation of how do we balance out the new future.
Yeah, that's interesting. What about collection? What about a different collection for the the water coming from the snow melt with all this salt? Is this been done already? Like separating, not infiltrating that? Because usually,
that's certainly
paved areas, not unpaved areas, right?
Yeah, that's certainly one of our greatest concerns. When we write our guidance manuals and design infiltration practices in northern areas, we make sure that there are devices to make sure that we divert the water around the infiltration areas. It's certainly going to kill any vegetation on the roadside in most situations, but it's also going to kill the soil. So we want to, unfortunately, we have to end up discharging it to the surface waters, which hopefully get flushed through the system, which maybe creates problems there, but it doesn't create the longer term groundwater problems or the soil problems with sodium absorption ratio that Shirley mentioned and affects it on in that. So that's certainly one of the operational considerations, certainly with infiltration of snow melt, is that you don't want to do that if you are salting that area. Rooftops in a residential area should not be a problem. Sidewalks, except, in residential areas are a problem because people put a lot of salt on their steps and their driveways and their sidewalks, but the roof, not so much. So again, it's a question of maybe that could be separated out. Who knows? But it's going to take a lot more attention than we probably are currently giving it.
Yeah. And many of our older urban cities, our northern cities, a lot of them are already built out, and there's a challenge of trying to separate parts of the system again. My campus, we have multiple pipes, multiple inlets, and I'm not seeing my campus investing. And I'm not seeing anybody investing in trying to put some sort of a reverse osmosis or some sort of forward osmosis membrane at either the inlet or at the pond outlet. And this is one of those challenges. And, how we're going to address it, it is salt could be treated if we had the financial ability to do it, but it's going to be prohibitively expensive. But I can promise you, I don't have, my inlet to my pond doesn't have power to run any of those types of systems. What we're actually seeing up here is that many of our systems, stormwater systems, are being planted with native plants, but they have expanded the definition to basically include the coastline. So rather than being, for example, central Pennsylvania native, they're now mid-Atlantic dune plants they're putting in these systems in order to handle the salt load. And so that is one of the challenges, not that it's necessarily picking up the salt, but their plants are not dying. So that when they want an aesthetically pleasing system, they have that. But it is, this is one of the challenges, is the migration of sodium, particularly of chloride, to the groundwater. And you can get some delay. There is a slight amount of soil reactivity, but I'm going to use the word slight and extend it out, go slight. It's not much. It's not a solid peak, but it comes through pretty quick. It's not far behind. The residence time of chloride in the soil is just not that long.
Well, again, it's if there was going to be requirement for treatment, of snow melt, then we'll certainly see that the alternatives are going to be much more viable. The other thing too, I mentioned with my rooftops, I was speaking, and I should be more specific, something like a rain garden for a rooftop should be fine. There's not going to be any salt application in most roofs. When I lived in Wisconsin, the first couple of winters, I said, why are all those snow plows parked on top of the flat roof buildings? So there is they were blowing the snow off the buildings, because the snow certainly is a bit unusual, but obviously the runoff from that, can be, is not going to be salted. And so that could be infiltrated through an adjacent rain without an issue. But in our research we did, like in Cincinnati, with infiltration areas, the first year, all of the rain garden infiltration areas had totally gotten destroyed due to sodium absorption problems, and the vegetation died. So those all had to be restructured and rebuilt. So again, it's an economic question. Once you consider the costs of repairs or management like that, then we start looking at use of less salt or alternatives.
Yep.
Treatment is not likely going to be an issue for sodium chloride.
Yeah, that's a very, very, very interesting topic to work, right? There's lots to be done. Actually, that brings us to the next question: is for those who reads your book, how is the stage of research for quality urban hydrogeology? What is needed, and how do you see the future of this field? In summary, would you recommend someone to work with that, to study that? You think it's a good thing?
Absolutely. I'd recommend studying it. We need more people.
Yeah, we need more funding.
That too. I'll be glad to study. I'll be glad to continue to study with a lot more funding.
Yeah.
No,
I mean, my answer to that thought process is trying to tie together the challenge of disturbance of soils, understanding depth of disturbance, how that impacts flow rate, which then impacts recharge, in addition to the quality issue of how does both our engineered media systems and the native soil down below those systems interact with the various pollutants, and what kind of treatment can we expect to protect the groundwater, is still a wide open field. I mean, a lot of us are trying to tie all these pieces together, but there still are a lot of things that we don't totally understand. And, again, building on work that Bob did years ago that I was peripherally associated with, we also don't understand, in some cases, recovery from disturbing soils. So there's a whole issue about how many years does it take of having earthworms, or in his case, fire ants, tearing through the soil to restore infiltration capacity. Are there ways to remediate the impact of sodium damage in urban soils? Again, I mentioned the karst balance. That's another challenge. There's a stack of things. And again, then you start dealing with historical or current problems of sewage, of industrial pollutants. And again, while the United States has a lot of treatment, there are plenty of places in this world where industrial pollutants still end up in a treatment pond, theoretically. An open pit in the back of the business, which then could infiltrate to the groundwater. There's still a lot of challenges there. There's a lot of work to be done.
When you're talking, I always remember my supervisor, my PhD supervisor. He used to say, Everton, you ever finish a research, your conclusion is a demand for funding,
Exactly, of course.
Because you never answer all the questions.
I tell my students that if you ever see an article that says what the next steps are, chances are they've already put the grant application in. Because if they're going to tell you what they think the next question to be answered is, they've already tried to figure out who to ask for money for it. But none of these problems can be solved without the research. I mean, we can do a lot of modeling, we can do a lot of speculation, but when you're working in urban areas, to me, that's what's always been challenging. And the fun part about it is there's a reason why urban land, in at least the U.S.'s Web Soil Survey, is called urban land. It's because it's a mix of compaction, native soil, cut and fill, soils imported from other areas, construction debris, all of these things. And it's such a mix that trying to understand, it's a lot of fun, but it's a real challenge.
What about someone who's not doing research, working in urban hydrogeology? People doing consulting or going for project or companies. What do you think as a field for work? Is that okay?
Yeah. Well, again, I think our concern has been being too narrow in their focus, and they have to be. If you're a consultant, you're being funded to solve a specific problem, not to make more problems. By looking at these other issues they should be aware of. And in engineering, that's always the case. We really need to address the problem that we're given, in a cost-effective manner, give them a nice solution, but we're not doing our job unless we talk about what the unintended consequences of that may be. And too many engineers or consultants are not aware of that or are not communicating that to their clients. And I think that's the big tragedy. And hopefully a project like your ebooks and Groundwater are going to, educate folks to be a little bit broader, in their considerations. It's not out of sight, out of mind, or the solution to pollution is dilution, and all these things we did 100 years ago, it's not really very relevant these days. So we got to be much more aware of these other problems that we're causing.
I think that I was going to add to that. That to me is what the exciting part of this Groundwater project is that those ebooks are going to be available, and they're broken. At least the ones I've seen posted so far are broken into topics that people can kind of grab a book on the topic they need, but see all these other resources out there to realize exactly how complex this issue is. I've had students who have looked at some of that, and in our area, we are looking at some of those groundwater surface water interactions. And we've had students as geologists come back and get an engineering degree. And so they do understand that, and they're able to communicate it to their clients. And in some of our water resources planning, this is becoming a critical issue. And so I think we are heading to that part of it. And so that consultants that are working in that field and working for those clients are going to be thinking about it, whereas those that are designing a development of a housing development or a commercial development probably aren't as much. But hopefully the guidance documents that are being vetted by engineers, scientists, researchers are going to raise some of these questions. So at least the simplistic design guidance, the basic straightforward design guidance has thought about it in terms of what we recommend for infiltration rates and things like that. We recommend about what waters, as Bob said earlier, what waters cannot or should not be infiltrated without pre-treatment. That's going to tell them there's an issue, that they don't necessarily have to understand exactly all the complexities of how gasoline interacts with soils to remove benzene or ethylbenzene or whatever. What they do know is that you shouldn't infiltrate that water without pre-treatment. And so a lot of the guidance documents that we're seeing coming out of our regulatory agencies are trying to take this body of research and boil it into some do's and don'ts, or do this with this caveat. And I think maybe that's the way we're addressing that, so that those consultants that are in for a project and may not have a groundwater background, at least are given guidance that encourage them not to do something that's going to be harmful. And so I think that's how we address it. That's what I'm hoping we're getting towards. Because we're not going to have, in our small engineering firms here, we're not going to have a groundwater expert in a land development firm. But they also don't want to hurt anything. I mean, they're not out there to try to hurt something. They're trying to meet the client needs. And so that's where that guidance information has to account for that, even if it doesn't necessarily show the direct link.
Good, good. So guys, it's a good talk, but we have to finish. We'll soon meet again, because we'll introduce your next book. It's soon to be released with us. Please, would you make your final statements? It was a lot of fun talking to you. Great. We'll see each other pretty soon. Please.
Yes, I enjoyed the conversation. Certainly good topics. I specifically enjoyed preparing and working on the ebooks as an opportunity to put a lot of material together, I think, to try to tell a nice story. You know, there's just little pieces of things in there, obviously, but hopefully there's enough information for the readers to take that information with the references and citations and the other ebooks to continue on for more in depth. But I really appreciate the opportunity to work with you guys in preparing these. Thank you.
I would agree with that. I appreciate the opportunity. I think this is a super exciting project, and I'm coming at it both as the teacher and as the person who helped prepare this ebook. I'm super excited about it. I'm looking forward to sharing this with my students. And I do agree with Bob. I hope that people enjoy that and have a chance to dig into the references and think about how this may impact the work that they do.
Thank you. I did enjoy it, and it was a great job. And people will have a lot of fun learning from your book. I'm pretty sure about that. And if you're downloading our book and you're watching this interview, please, should you know that we have star volunteers like Bob Pitt and Shirley Clark helping us, and consider making a donation to our institute. We're living on volunteers, and we have some costs to cover. Your donation would be very welcome. Thank you, guys. Thank you, Bob. Thank you, Shirley. Very nice.
Thank you.
Thank you.
Great to talk with you.
Thank you. Bye.
Bye.